All right, here's video number 3. Video number 3 on how to solve a quadratic equation. So I have a little typo here. It says solve my quadratic equation. It should not say only works if the equation can be factored. It should really say always works. All right, and so we've got, this is the quadratic formula right here. First of all, this is not negative b. This is, I would refer to it as the opposite of b. Don't say negative b. So it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So you got to make sure this equation is equal to 0 and in standard form. So it's in standard form, a, b, c equals 0. So first thing's awesome. And then the first step we got to do is figure out what's a, what's b, and what's c. Okay, so c is this constant term here, that's negative 18. B is the coefficient of x, that's negative 7. And then a, there is no number here, so it's just 1, positive 1. All right, so that was pretty easy. Then we got to substitute it into the formula. Now, you're not going to have enough room in here, so just go to the opposite page of your notebook, and you should have plenty of space. So remember we said A is 1, B is negative 7, and C is negative 18. So the formula is the opposite of B, so I'm going to put the opposite of B, 7, plus or minus the square root of b squared, so that's negative 7 squared, minus 4 times a is 1, times c is negative 18, okay, all over 2 times a is still 1. So there we go. All right, so I've substituted everything in. Now I just need to evaluate. I'm going to start with the discriminant right here, okay. So you got to remember, negative 7 squared, that's a negative times a negative. That's going to give me a positive. So I'm going to have 7 plus or minus the square root of 49 minus, and then I'm going to go ahead and multiply negative 4 times 1, which gives me negative 4, times negative 18, which gives me positive 72. And it's positive because a negative times a positive is a negative. That's negative 4. And a negative times a negative is a positive. So that's how I'm getting positive 72. Still all over 2 times a. I will go ahead and add these and multiply these. So I still got 7 plus or minus. Now if I add these, I get 121. And if I multiply these, I get 2. Okay. Now, if you look in your notes, it says you must add and subtract to get the 2 different answers because this is a quadratic equation. It should have 2 different answers. So I'm going to add first. 7 plus, well, the square root of 121 is 11 because 11 times 11 is 121 over 2. I add these, I get 18 over 2. I get 9. So my first answer is 9. Now, I need to get a second answer, and I'm going to do that by subtracting. So it'll be 7 take away 11 over 2. And 7 take away 11 is negative 4 over 2 is equal to negative 2. So there is my other answer. So I got 2 solutions, worked out great, which almost never happens in the real world. If you look at the notes down here, right here, it says you may need to leave the answer in radical form. So I'll just give you an example of what that would look like. Let's say you were doing all your math and you had like 2 plus or minus the square root of, and this ends up being like, let's say 10 over 7, let's say. If that happens, you just write the one answer as 2 plus the square root of 10 over 7. Oops, just put the wrong thing there, over 7. And 2 minus the square root of 10 over 7. And you'd be done. Those would be your 2 answers. So oftentimes that happens, that whatever ends up being an indiscriminate actually is not something you can find the square root of. It's not a perfect square. You just write it in this format and you're done.